Hello friends, today we will study Quicksort. Quicksort is a divide and conquer algorithm. In Quicksort, we'll assume the first element as pivot element, and if we are sorting this array in ascending order, then we'll partition this array into two parts such that the left part of the array after partitioning contains the elements less than pivot and right part will contain the elements greater than pivot. So here is how we'll do it. As I said, I'll assume the first element as pivot element. So 10 is the first element in this array A. So this will be our pivot element. So to partition this array into two parts, I'll take a variable I which will help me do this. I'll initialize another variable j to the last position. So I'll increment I till I find the element greater than pivot. So 6 is less than pivot, so let it sit there. I'll go to this place. So 20 is greater than pivot, so I got the element greater than pivot, so our I will stop there. Now I'll start from this end in order to search an element which is less than pivot, because we don't want lesser elements in the right part. So 18 is greater than pivot, so let it sit there. So decrement j. So here I have 4 which is less than pivot, so I found one which is less than pivot. Now I and j have not crossed each other. I is still less than j, so we'll swap the element on ith position with the element on j's place. So I'll bring 4 here and bring 20 here. I'll repeat this from I. So I'll go to this place. So the element here is 1 which is less than pivot, so let it sit there. Go to this place. The element here is 50 which is greater than pivot, so our I will stop here. Now we'll start from j and searching for the element lesser than pivot. So I have 25 on this place which is greater than pivot, so let it sit there. I will go to this place. I have 9 which is less than pivot, so our j will stop here. Now I and j have not crossed each other, that means I is less than j. So if it is so, swap I element with j element. So I'll bring 9 here, I'll bring 50 here. Then continue with j side, I side. So go to this place, bring I here. So this is less than pivot, so let it sit there. Go to this place, I have 50 here which is greater than pivot, so our I will come and stop there. Now decrement j till we find the element lesser than pivot. Go to this place. So here I have 7, so 7 is less than pivot, so our j will stop as soon as it sees the element less than pivot. Now if you observe, this time I and j have crossed each other, that means I has become greater than j. So this time we will not swap a of I with a of j, but we will swap the pivot element with j. So I'll do this swapping. So I will bring 7 here, I bring 50 here. So this is the place of partitioning. Right? So if we rewrite the array, so 10 is the pivot, so I brought 10 from here to here. So here is the place where our pivot is sitting. So if you observe now, the left part of the array, that is left to pivot, all the elements are less than pivot, and if you observe the right part of the pivot, all the elements are greater than pivot. That's what we wanted, that's what the partition we desired. So we got partition of the array containing lesser elements in the left and greater than pivot in the right. So now we'll repeat this procedure for the left part. So this will be my pivot. Here is my I, here is my j. Increment I till you find the element greater than pivot. So 6 is lesser than pivot, 4 is also lesser than pivot, 1 is lesser than pivot, so 9 is greater than pivot. So our I will stop here. Now decrement j till you find the element lesser than pivot. So 1 is lesser than pivot, so our j will stop here. Now if you observe, I and j have crossed each other, so this time we will swap pivot with j. So this is the place where pivot is sitting. So 7, 9, 1, 6, 4. So this is the left part, this is the right part. Left part containing 3 elements, right part containing 1 element. So we'll apply quicksort on this part. So this will be my pivot. This is my I and this is my j. Increment I till you get the element greater than pivot. 6 itself is greater than pivot, so I will stop there. Decrement j till you find the element lesser than pivot. 4 is greater than pivot, so decrement j. 6 is also greater than pivot, so decrement j. So 1 is less than or equal to pivot, so our j will stop here. You can't decrement j further because this is the last element of this array. So now I and j have crossed each other. You should swap pivot with j, but pivot and j are really the same element. So after partitioning, pivot will sit there itself, and in the right part I'll have 6 and 4. So this is the right part. Left part contains nothing, so we need not worry, we need not sort. So right part contains 2 elements, so we need to sort them. So this will be my pivot, and this will be my I, and also this will be my j. Increment I, but can't increment because this is the last element. Decrement j till you find the element lesser than pivot. 4 itself is lesser than pivot, so I and j, I will stop there and j will also stop there. Now this time also I and j have crossed each other, so we will swap pivot with j. So here is our pivot. I'll bring 4 here and I'll bring 6 here. So we got the partitioning like this. So here is where pivot sitting. The left part contains 4, right part contains nothing. So in the left part I have only one element, that is 4. I need not sort. Right part contains nothing. So here our procedure terminates, and by this time if I rewrite the entire left part, it will look like this. I have 1, 4, 6, 7 and this 9, and here is where our pivot origin, the first pivot is sitting. If you observe the left part, it is sorted ones in the ascending order, 1, 4, 6, 7, 9. Similar procedure can be applied on the right part. So if you do this quickly, we'll do it. So 50 is my pivot. Here is my I and here is my j. Increment I until you find the element greater than pivot. So 25 is less, 20 is less, 18 is also less, but we can't go further because this is the last element. Decrement j till you find the element less than pivot. So 18 itself is less than pivot. So this time if you observe I and j have crossed each other, so swap pivot with j. So I'll bring 18 here and I'll bring 50 here. Okay. So if you observe left, observe pivot is sitting here after partitioning. The left of pivot contains 18, 25 and 20, and pivot is sitting here. Right part contains nothing. So apply quicksort on this part. So this is pivot, this is I, this is j. Increment I till you find the element greater than pivot. So 25 itself is greater than pivot, so I will stop there. Decrement j till you find the element less than pivot. So 20 is greater than pivot, decrement. 25 is greater than pivot, decrement. So 18 is the last element of this array, so j will stop here. Okay. And I and j have crossed each other, so swap pivot with j, but pivot and j are really same. So pivot will, after partitioning, will set there itself. So left part will contain nothing, right part will contain two elements, that is 25 and 20. So sort them. Assume this as pivot, this is I, and this is j. So increment j, but when can't increment, this is last element. So decrement j till you find the element lesser than pivot. So 20 itself is lesser than pivot, so j will also stop there. So I and j have crossed each other, so swap pivot with j. So this was our pivot, we'll swap this with 20, so 25, and I'll have 20 here. So now if you see, pivot is sitting here and left part contains only 20, right part contains nothing but 20 is the only element. We need not sort it, it's already sorted, right? So right part contains, so here our procedure ends, and if we rewrite the left part, entire right part, it looks like this: 20, so 18, 20, 25 and this 50. So thus, if you see, the entire array is sorted. So if I just summarize what we did, we start with the first element as pivot, search the elements from left hand side which are greater than pivot, and search the elements from the right hand side which are smaller than pivot, and swap them. So continue this procedure till our I and j crosses each other. Once I and j crosses each other, swap pivot with j, right? And after that, the position of the pivot is the partitioning point. So the array from left index till pivot position -1 is the left part, and array from pivot position +1 till the right index is the right part. So recursively we apply the same procedure on the left hand side as well as right hand side till we get the left and right hand side sorted. Thank you.